Right, well that was a really fine example of a bad catch. That kind of catch scares the daylights out of people when they first try the skew, but you're actually pretty safe. The wood's held between centres, it's not going to jump anywhere, you're pretty safe. Whereas if you have a catch with a bowl gouge, they're much more dangerous, you get hurt with those. So I'm going to clean this up a little bit and then we'll come and have a look and see why that happened. Now this is the right way to use a skew. First, the bevel goes on the wood, and you rotate the tool until the dust comes over the edge, then you move the tool forwards. And then I can roll the tool over and go in the other direction. And notice here, as the cut proceeds, the bevel stays in contact with the wood. If you raise the bevel, then you'll end up with a cleanly cut surface, which is ridgy. And as I raise the bevel, you'll hear the tool begin to chatter. If you see cleanly cut ridges on a piece of wood, that's always a sign that you haven't had the bevel rubbing, either with a gouge or a skew chisel. You can also use the tool long point down. The advantages are that any pressure you put in the cut are going directly towards the headstock, and you've got much less pressure against the axis. Bevel on the wood first, roll the tool, pivot it slightly until the dust comes over the edge. That's a pretty good finish off the tool. So that's all going along very nicely, but let's have a look at why tools actually catch. The simplest form of the catch is when you put the tool on the wood before the rest. And it's just a quick bang. And it usually messes up the wood. So let's have a look at why the skew catches. When you're using the skew, you should be using the leading half of the edge, and when you're doing that, the wood is coming down on the far side of the fulcrum from where you're holding the handle. That's represented by a line here, so the fulcrum is where the tool's sitting on the rest, and there you have control of the leverage. If you let the point of the cut come your side of the fulcrum, then there's space in underneath here, and the pressure of the wood is on the unsupported part of the tool, so just get that shaving out of the way. That means the point's going to dig in and the wood will just drag the tool down onto the rest. So if we look at that with the lathe running in slow motion, we'll see it happening. So I'm fine when I'm cutting there. If I let the point of the cut come to this side, juddering around, and then you can see that with the point coming in, it's going to start jumping back. Speed goes up and I'll get rid of the original catch. If we look at the catch I had initially, we can see how the same principle applies when you're cutting a bead. That happened before I meant to. The genuine article, folks. And generally when I do this, I prefer to have an underhand grip when I'm cutting a bead. So I have two options for cutting a bead. One is to use the corner. The tool comes along the rest as it's rolled onto its side. And so I'm using just the short corner of the tool, and the only portion of the tool in contact with the wood is the lower bevel here. If I let the bit I've just cut, which I'll mark with a pencil up here, if I let that area get onto the edge, to there, then it's going to want to catch back every time. Yep, so that was even better or worse, if you like, than the last one, and you should have seen the cameraman jump back. So after that little gem, we'll have a look at why you have catches when you're cutting V-grooves. So what you're aiming to do here is to cut with the point of the tool and just have the bevel side in contact with the bit of wood you've just cut. In other words, with the side of the groove. Now, catch coming up. As I come down here, if I let the wood get onto the edge, another real goodie. Now I'll just show you that from the other side. Roll it over. Right, so that's another gem, and it's a matching set, kind of ram's horn. Now, the reason that caught is because I should have been using the long point, only if the wood gets onto the edge, which it did somewhere in there, then the edge is unsupported. There's space in underneath here, and that's why it kicks and runs back. So what we've got here is a little bit of a spindle with about every nasty catch you can have with a skew chisel, and we're still safe. It's still between centers. So as I said earlier on, they're really not that dangerous. They just mess up the wood. When you're making a bowl, there are lots of opportunities to have good catches with a gouge. So first we'll look at the catching opportunities when you come around the corner, when you first start to shape the outside. And then we'll see how that applies on the inside a bit later. When you start with the deep fluted gouge, have it right on its side to start with, and then you're going to roll it up into the cut as you swing it in to the edge. If you bring it in, flute up like this, first off there's space underneath the point of contact in there, and you're likely to have a catch. When you get better at it, a little bit more experience, then you can probably bring the tool in at this angle. But to start with, be on its side and then roll it up into the more dangerous position. That's taking the outside off, typically just 2 or 3 cuts. Now let's look at some finishing cuts. So the aim here is to keep the bevel side rubbing against the wood, but you've got to be very careful not to roll the tool too far over, because if you start cutting up on the top edge, there's space underneath the point of contact and the tool will catch, guaranteed every time. Okay, and now let's look at exactly the same cuts, but with a spindle gouge. Again, coming up the side, I'm going to use this wing of the tool. The tool starts right on its side. This is the 1/2-inch spindle gouge. Drop the handle to get a better shaving. So that's a typical roughing cut. Now to get a smoothing cut, move the rest a bit lower, have the tool pointing in the direction I want to go, raise the handle to pivot the edge into the wood, and off I go. Now you see here with a shallow gouge, I'm using the nose of the tool to get the shaving. If I bring the flute so it's upright, in the same position I had it on the deep fluted gouge, I've got a guaranteed catch every time because the wood is down on an unsupported edge. These aren't catches I like to show, they're far too dangerous. So having seen the outside cuts on the profile, we're now going to look at what happens on the base. This is still a shallow gouge, the spindle gouge, and if you want a guaranteed catch, just bring it in, flute up. If you do that, the wood will come down on the unsupported edge and it will fall over every time. And if you're doing that kind of thing, you're probably hanging on white knuckles, so the catch will be even worse. What you have to do is to start the tool on its side, get yourself a smooth surface on the rim, roll the tool over, and then take the shear cut back into center. Hands on the rest, just squeeze the tool in gently. Get the bevel riding, raise the handle, pivot the edge into the wood, then move forward. And we'll just show you how the shaving comes off the tool. So it's coming off just above the nose of the tool. Now let's look at the deep fluted bowl gouge. With the deep fluted bowl gouge, this is the 1/2-inch deep fluted bowl gouge. I'm going to use the left wing with the tool roll right over on its side, so the flute's facing towards the wood, and just use that wing to trim up the edge. Then I can roll the tool over, get the bevel riding. Now I've got 2 options here. One is to use the top of the tool rather as I did with the shallow gouge, or I can have a back cut, which is using the higher wing here with the flute upright. And I can do that. I can do that because the inside, the flute on the side here of the gouge is steep. So you really need to appreciate the difference between the two gouges. When you look at them end on, the shallow gouge, the spindle gouge, doesn't have the steep bevel that the bowl gouge does. Right, now we've got another bit of wood, and we'll have a look at catching a scraper. This is a big bowl scraper, and I'm going to be going across the bottom of a bowl. So, if you don't keep the tool flat on the rest, you're going to have a catch. Didn't see too much of that there, but it certainly did a bang. The important thing with a scraper is that the angle between the surface you're cutting here and the top of the tool is a negative angle, which means it's less than 90 degrees. If you tilt the tool up, so this angle is more than 90 degrees, that means if the tool digs in there, it's going to want to go through an arc through the wood. And then what happens is, of course, it kicks back. There's a current fad for negative rake scrapers. This is a Skew Chisel, which is in effect a kind of long beveled negative rake scraper, but that means if you keep the skew flat, then the bevel, the little bevel on the top, is going to make for a negative angle in there, less than 90 degrees. But you can still have a bad catch with a skew or with a negative rake scraper if you tilt it up steep enough. Negative rake scrapers are not a panacea. You can still catch the tool with them.